I get here? Must have been asleep for a few hours. Is that a periodic table? Must be. That means I'm in a chemistry classroom, aren't I? Mr. Kilbart, I'm afraid I kind of fell asleep in class. I don't really know how. Did I miss something? Like, did we do notes or something? Can you maybe catch me up here? I'm lost. That's Professor Kilbart to you, not Mr. Get that right, please, Johnny. Also, I don't know why you're asleep at all, because you just missed out on the most fascinating lesson in all chemistry, called the mole concept. But don't worry, I love it, so I'll catch you up on it, but just try not to fall asleep in class next time. Anyways, you might be wondering, what is the mole concept? Are you talking about the animal that burrows underground and is colorblind and has a terrible vision and has to rely on its sense of smell to catch its prey? Or are you talking about those marks on the skin that some people have? Well, technically those are both moles. However, there is another definition of the mole, and this is within chemistry. Another definition. What could it be? Well, I'll tell you. It is, behold, a number. A number? You said this was a fascinating concept, and it's just a number? What? You might be wondering that. And honestly, when I first learned about it, I wondered the same thing. How is much of chemistry revolved around a number? Just a number. But let me tell you this. Do you know pi in mathematics? 3.14, 15, 92, 65, 35, and so forth. And yet almost everyone knows about it. But technically, it's just a number. We use it for a lot of formulas in terms of circles, but it's such a key component of figuring out circumference, area, etc. of circles. Well, in chemistry, the mole works in a similar purpose. It's kind of a basis or a baseline for a lot of conversions and mathematical calculations in chemistry. So you ready to hear what it is? Well, you've come to the right place because I got it for you. Get this. It's going to be unbelievably large. In fact, so large that you won't even be able to visualize it. But I'll help you. I'll give you an example of how large it is after. But first, it is, get this, 6.022 times 10 to the power of 23. 6.022 times 10 to the power of 23. Wow! That is unbelievably large. And let me tell you just how large that is with an example. If you receive 1 mole, 6.022 times 10 to the power of 23, amount of pennies when you were born, and spent $1 million worth of these pennies every second until you were 100, well, guess what? When you're 100, you'd still have over 99.99% of them. That many, you're spending $1 million in pennies every single second until age 100, from 0. And you still have over 99.99% of them. Unbelievable. That's how large of a number it is. Essentially, a mole is referring to the amount of atoms or particles within element or compound, respectively. For example, a common everyday item, such as this pencil case right here, probably has moles and moles of particles within it. And yet it's relatively small in everyday life. Just imagine how many moles of particles there are in your body, for example. Many and many, all working together to keep you alive and breathing. It's unbelievable. 6.022 times 10 to the power of 23 is 1 mole. Now, before we get into example problems and I have some work with moles, let me just give you more background information to get you more familiar with the concept of it. Now, if you've ever worked or seen a periodic table before, you're likely going to be familiar with a term called atomic mass. Atomic mass is a number on a periodic table. Now, for hydrogen, that atomic mass is 1. For helium, it's 4. For lithium, it is 6.9. Beryllium, it is 9, and so forth and so forth. It's a number, and it's getting larger generally as you go from higher atomic numbers to the more higher atomic numbers. Generally, it gets higher. But there's no unit to it. It's simply just a number, right? So that might confuse you a bit. And honestly, I'll admit I was initially confused when I first started using a periodic table. Why is there no unit? What does this number mean? Well, essentially, I'll tell you this right here. That number essentially tells you the amount of grams it takes of that element in its pure form to make 1 mole of atoms, or to contain 1 mole of atoms, I should say. Now, to put this more clearly with an example, the atomic mass of carbon is 12. 12. Obviously, there's actually decimal places, but it's generally used as 12. What that means is if you have 12 grams of pure carbon, you will have 1 mole of atoms. If you had 6 grams of carbon, which is half that amount, you'd have half a mole of atoms. And like I said, a mole is 6.022 times 10 to the power of 23. If you had 1 gram of carbon, you'd have 1/12 of a mole. So 1/12 of 6.022 times 10 to the power of 23 atoms. Or moles, I should say, which refers to atoms. That is essentially what atomic mass means. And many, many years ago, a couple centuries ago, it was discovered that carbon-12, coincidentally, as I've just been speaking, had 12 grams of it had 6.022 times 10 to the power of 23 amount of atoms. So, atomic mass of each element is expressed relative to carbon-12, and it is relative. So, as I've just discussed, 1 mole is the number of atoms in 12 grams of carbon-12. But again, this can apply to any element on the periodic table, right? So 132.9 grams of cesium, because that's the atomic mass, 132.9, will have 6.022 times 10 to the power of 23 amount of atoms, or essentially 1 mole of atoms. Now, that is essentially the concept, the foundation of the mole in chemistry. You work with this in so many different units, such as acids and bases, stoichiometry, dynamic chemical equilibrium, and reaction kinetics, just to name a few. But as you can see, it's a foundational concept for many things, such as unit conversions especially, or molarity. Primarily the problems that you'll see with it is converting from one unit to the next. So that's essentially what this concept is, and you use it a lot for that purpose. You can figure out the amount of a substance that you have. You can figure out the amount of liters of a gas you have. You can also figure out the amount of particles a compound has, all from just knowing moles, or from other things. And you can totally figure it out. Now, in this lesson today, I got to keep it short because it is lunchtime. I got my break ending soon. I got a class to teach in just 2 minutes. Johnny, you're going to have to come in for the next 5 days at lunch in order for me to catch you up and everything that you missed, because there's more units that you missed too. Stop falling asleep in class. Now, I'm gotta go for now, but next time for lunch, you come in here and we're going to work through some example problems regarding moles. But for now, I'll just leave you with that. That is the idea behind a mole. Johnny, take care. I better run to my next class.